Voyager 1, by NASA, which currently holds the distinction of being the most distant human-created object, has captivated people all over the world for almost 5 decades since its deployment. Voyager 1 has transmitted crucial information from the farthest reaches of outer space, enhancing humanity's comprehension of the universe. Nonetheless, recent broadcasts by the probe have exhibited anomalous irregularities that experts have been perplexed by. These enigmatic signals have sparked vigorous debate, causing the scientific community to wonder whether these oddities are mere technical glitches or indicators of something far more astonishing, possibly even participation from aliens. As we delve into these bewildering messages and investigate the potential hidden away in the endless expanse of the universe, the innate human urge to uncover mysteries has long fueled our pursuit of space exploration. This profound inquisitiveness paved the way for daring initiatives like Pioneer 10 and Pioneer 11, which ranked among the most daring ventures into space of their time. On August 20th, 1977, the beginning of Voyager 2 from NASA's Kennedy Space Center initiated a groundbreaking era in space research. Soon after, on September 5, 1977, Voyager 1 was sent into space, beginning a voyage that would lead it to the outer planets, dramatically altering its route and scientific outcomes. Each probe, with a mass of around 721 kilograms, comparable to a small vehicle, ventured in distinct directions at different speeds. On December 15, 1977, an important achievement occurred when Voyager 1 beat its sibling in terms of distance covered due to their divergent paths. Since then, Voyager 1 has served as a vital asset in deepening our perception of the provision of space discoveries that have altered our methods of understanding the universe. Before diving into some of its recent revolutionary findings, let's revisit several of its earlier key accomplishments. In 1979, positioned roughly 265 million kilometers from Earth, Voyager 1 obtained high-resolution images of Jupiter. As early as January of that year, it had finalized an impressive 100-hour study, resulting in a time-lapse sequence showcasing Jupiter's rotation. This set of 3,650 images delivered unmatched insights into the turbulence of the planet's atmosphere and complex features. During this expedition, Voyager 1 also detected a previously unidentified ring around Jupiter and found 2 unknown moons, greatly improving our knowledge of the gas giant's intricate system. To maintain its course and avoid colliding with Titan, one of Saturn's moons, the probe executed several navigational adjustments. Following this, the mission shifted its focus away from the Sun's system planets as the spacecraft was rerouted into interstellar territory, traveling at an extraordinary pace of 325 million kilometers per year. In January 1990, Voyager 1 began its assignment to investigate interstellar space, pressing onward beyond the limits of our solar system. During this phase, it accomplished several exceptional feats, such as identifying 4 new moons, Mimas, Enceladus, Tethys, and Rhea, as well as some of the most enduring images of the solar system's outer boundaries. On February 14, 1990, located approximately 6 billion kilometers from the Sun, Voyager 1 took a panoramic portrait, the iconic family collection of images of the inner planets. This 60-part compilation of photographs was incorporated into the mission's extensive gallery that already included dozens of images from its conclusion encounters with the gas giants. Voyager 2 simultaneously achieved remarkable accomplishments during its journey. On Neptune, it measured wind speeds that topped 2,100 km/h, roughly 2,300 mph, the swiftest atmospheric currents ever documented throughout the solar system. It also observed Triton, Neptune's largest satellite, in which temperatures fell to a chilling 391 degrees, ranking it among the coldest known locations. Triton showed signs of icy eruptions spewing nitrogen gas and frozen debris up to 5 kilometers high, revealing fascinating new aspects of its geology. These phenomenal findings significantly broadened our grasp of the varied and vibrant conditions in the solar system. The impact of Voyager 1 and Voyager 2 has been truly transformative. Their discoveries revealed previously unknown characteristics of Saturn and Jupiter's moons, once thought to be inactive. This new evidence redefined beliefs about their geological activity. Voyager 2, in particular, stood alone in history as the only spacecraft to date to pass close to both Uranus and Neptune, an unparalleled achievement. NASA made use of a number of creative tactics to extend the lives of these groundbreaking missions, like powering down non-essential components to conserve energy. The endeavor is expected to persist until 2030, illustrative of the conclusion of a remarkable chapter for the teams who devoted themselves to this mission. The construction of Voyager 1 and Voyager 2 exemplified advanced design and engineering. Built to rotate slowly, these probes minimized motion blur in their images during travel. Even before arriving at the outer planets, the spacecraft began transmitting specific visuals of Jupiter, unveiling its swirling clouds and the well-known Great Red Spot, a gigantic storm that has piqued scientists' interest for decades. One of the most exciting findings was the detection of active volcanoes on Io, the moon of Jupiter. Instruments aboard the spacecraft picked up peculiar readings from the moon, later proved by pictures revealing massive volcanic plumes and a violently reshaped surface. One eruption on Io was found to be 1,000 times more forceful than Mount St. Helens, blanketing an area nearly the size of France. As their voyages continued, both spacecraft were gradually powered down to save fuel before heading into interstellar territory. Strikingly, they didn't capture images of Mercury or Mars due to technical constraints. NASA later launched additional noteworthy missions, including Pioneer 10, Pioneer 11, and New Horizons. On February 17, 1998, Voyager 1 surpassed Pioneer 10 to become the most remote probe from Earth. Despite this, Voyager 1 pressed on for another 14 years before officially entering interstellar space on August 25, 2012, an important contributor. To these successes was the strategic use of gravitational slingshot maneuvers, which catapulted the spacecraft toward their targets while saving fuel. Instead of relying solely on the power of the engine, they used the gravity of the planet to increase speed and change course. This allowed them to traverse enormous distances with minimal consumption of fuel. As Voyager 1 got closer, Jupiter's immense gravitational pull accelerated the spacecraft. Pinpoint accuracy was vital to prevent dangerous shifts in speed or direction. These gravity assists enabled the probes to navigate the solar system with skill. Voyager 2 likewise used gravity from Jupiter and Saturn to propel itself toward Uranus and Neptune, proving the method's efficacy. Looking back at these remarkable missions, the scientific community eagerly anticipates new understanding from the baffling signals Voyager 1 recently discovered. These explorations continue beyond the outer boundaries of our solar system, figuring out the secrets of planets like Jupiter, Saturn, Uranus, and Neptune. Voyager 1's time-lapse sequences vividly documented 10 eruptions on Jupiter and revealed new satellites and a previously unnoticed ring encircling the planet. These breakthroughs substantially advanced our understanding of the Jovian system. Likewise, Voyager 1 identified 4 additional moons of Saturn, Mimas, Enceladus, Tethys, and Rhea, while also delivering breathtaking imagery of the planet and its rings, illuminating its complex structure. The mission's excursions to Uranus and Neptune generated essential data about their satellites and atmospheres, enhancing our understanding of the entire solar system. After completing their planet flybys, both probes aimed for interstellar space, where they persist in continuing to collect important data. Research broadens our perspective on what lies beyond our solar system. As we await further revelations regarding Voyager 1's strange transmissions and their implications for our grasp of the cosmos, the amazing journeys of these investigations continue to motivate both astronomers and space enthusiasts all over the world. Their accomplishments remain essential to the development of humanity's knowledge and extending the frontiers of space exploration. Voyager's space exploration programs have provided us with unparalleled views of the solar system and far beyond, delivering iconic pictures and scientific findings. Together with these reveals, the spacecraft also carries an artifact with a symbolic message designed to share Earth's story with possible extraterrestrial intelligences. The Golden Record includes greetings in 55 languages, music from different cultures, and natural sounds like thunder and whale calls. This interstellar message in a bottle expresses humanity's hope that, beyond Earth, intelligent beings might eventually discover and comprehend it. The suites on Voyagers 1 and 2 were added later, consisting of scientific tools that dramatically improved our space knowledge. These included magnetometers, plasma wave sensors, and imaging devices, all of which offered key insights into the cosmos. Space. Conditions that were helped by the magnetometers decoded the magnetic fields of Jupiter, Saturn, Uranus, and Neptune, illuminating how these fields relate to one another. Environments that detect plasma waves explained how the effects of solar winds interact with planetary atmospheres. One of the mission's most notable triumphs was mapping the boundary of the heliosphere, a region filled with solar particles and electromagnetic fields enclosing our system. As Voyager 1 got closer to this zone, it sensed a shift from solar wind to interstellar matter, producing important details on how this boundary protects Earth from cosmic radiation. The spacecraft identified a definitive point, known as the termination shock, where solar winds decelerate and thicken. The heliosphere lies beyond that, where solar and interstellar particles collide, resulting in a lively and dynamic setting. The voyage of Voyager 2 significantly enhanced our grasp of the outer solar system. Its pass through the outer planets offered enormous, important observations, particularly regarding Uranus's magnetic field, which turned out to be positioned in a manner that defied existing models. These results encouraged more study into planetary science. These efforts have not only propelled scientific understanding but also rekindled interest in space exploration among the public. The stunning visuals of remote planets and the compelling stories that lie behind the missions have inspired people of all generations. The awe-inspiring images of Saturn's rings and Jupiter's volcanic moons have become iconic, motivating new scientists and space pioneers. As the Voyager crafts keep disseminating extraordinary information, their ongoing exploration of interstellar space offers unparalleled chances to grasp the very fabric of the universe. Though focus has often centered on our solar system's planets, studying interstellar regions has revealed unexpected complexities. Regions once thought to be barren now display intricate phenomena that challenge modern science. One of the most intriguing findings is the detection of cosmic rays that come from other star systems. These particles, with a lot of energy, provide clues at the speed of light about what's happening in other parts of the galaxy. By analyzing their energy and composition, researchers aim to better comprehend the workings of distant star forming, regions, and galactic dynamics. Furthermore, as Voyager 1 and 2 journey deeper into interstellar space, their instruments continue to assess the motion and density of the interstellar medium, the matter between stars. This medium, made of gas and dust, interacts with solar wind and influences the shape of the heliosphere. As the probes move through it, they send back key data that aid in modeling how energy and matter behave over vast distances between stars. In addition to these studies, the Voyager crafts have revealed a great deal about magnetic fields in interstellar space, offering details about their nature and influence. These insights may eventually lead to advances in understanding cosmic galaxies' magnetic forces. This continued exploration of space's distant boundaries not only extends our scientific knowledge, but also inspires upcoming generations of space researchers and engineers. The unforgettable images that Voyager captured, especially the renowned pale blue dot, depicting Earth from more than 6 billion kilometers away, remind us of our tiny place in the cosmos. These visuals, together with the discoveries made in science, have profoundly affected how we perceive our planet and its role in the universe. The success of the Voyager missions has opened doors to even more ambitious projects. With the innovations developed during their journeys, sending advanced probes to far-off regions of space is now increasingly plausible. Goals targeting exoplanets, in search of livable worlds and interstellar travel, are evolving from mere dreams into viable goals for the future of space discovery.